Good afternoon, morning, evening, everyone, depending on the time zone that you might be located. Thank you so much for joining us today. I am very happy. It's a real privilege to be here to moderate this panel on energy innovations in Australia and Canada. My name is Walter Merida, and I am the Associate Dean of Research at the Faculty of Applied Science in Vancouver, the University of British Columbia. And my area of work is clean energy, so I'm delighted to be here. I also would like to acknowledge that I'm joining you from the ancestral and unceded territory of the Musqueam people, on which our campus is located. And these grounds are very important to us in terms of our connection to the environment and to the land. And the topic today is really couldn't be more important, really. As we look at the transition to a new energy system and the decarbonization of the energy system, there is a critical connection between the technologies and solutions that we may propose and the way in which those solutions may be actually enabled and in the way that those solutions may become reality. And one of the most critical links is how are we going to obtain the materials and resources required to make that transition possible. So I'm delighted to have a world-class panel, really, of experts today that are going to talk to us about different aspects of those challenges and opportunities. So if I could go to the next slide, please. You can go to the next slide. I think no one needs to hear more about me. First of all, we have Professor Diana Kemp, who is the director of the Center for Social Responsibility in Mining and Sustainable Minerals Institute at the University of Queensland. And Dr. Kemp is specialized in industry-engaged social science that bridges company and community perspectives on extractive industries. And I'm really looking forward to some of her interventions later on in the panel. Next slide, please. We next have Dr. Ali Madise, who is the Canada Research Chair in Advanced Mine Energy Systems, and he's an assistant professor at the Norman B. Keble Mining Engineering Department at the University of British Columbia. Ali is a relatively recent addition to our faculty here at UBC, and I have had the pleasure of interacting him on a number of fronts. And I think you will find what he has to say about the mining sector in Canada very interesting. Next slide, please. Next, we have Dr. Nadia Kunz. She's an assistant professor and Canada Research Chair in Mine, Water Management and Stewardship at the University of BC. And like Ali, I have had the pleasure of interacting with Nadia on a number of occasions. And I'm delighted actually to have these recent additions to our faculty and the Faculty of Applied Science, because I think that the whole sector is ready for a big move and a big pivot into a sustainable energy system. Next slide, please. Next, we have Professor Chris Gregg. He is the Senior Research Scientist in the Adlinger Center for Energy and the Environment at Princeton University, but I understand he also had some previous links to Queensland, so I think he will be in good company here. Next slide, please. And now we have Professor Rick Valenta, who is the director of the W.H. Bryan Mining and Geology Research Center, also at the University of Queensland. And Rick is going to give us, I think, a good sense of the magnitude of some of the challenges that we are facing as we make that transition to a new energy system. So without further ado, I would like to get right into the focus of our discussion. And I would like to start with you, Chris, if you don't mind. Since the signing of the Paris Agreement in December 2015, we have seen a growing momentum among nations, states and companies who have made pledges and commitments to net zero emissions by around 2050. The target years vary, but 2050 seems to be the most common target year. Such pledges have come from the European Union, Japan, South Korea, China, and most recently the US, but also the likes of Shell, Ford, Cenovus Energy, and Qantas. At the same time, the European Union, the US, Canada, South Korea, and many other countries have proposed multi-trillion-dollar recovery strategies. clean energy and climate action are now part of a global narrative identifying the opportunity to, as they say, build back better. Some of these pronouncements have become national roadmaps, initiatives, and programs. And in fact, I'm happy to report that yesterday, our federal budget in Canada devoted significant funds to green spending. Some of these roadmaps and initiatives, I could give you a couple of examples. The Canadian Net Zero Emissions Accountability Act delivers on the Government of Canada's commitment to legislate Canada's target of net zero greenhouse gas emissions by 2050. And it was introduced in the House of Commons in November of last year. So in this, there's a lot of activity in this global context. I would like to ask you the following question. How well prepared are we to take on the transition to net zero emissions by mid-century? And what are some of the biggest challenges and opportunities to confront during a global green recovery?
Yeah, thanks, Walter. I guess the first thing I'd say is these net zero pledges are really important because, unlike the past when we were going to stay below 2 degrees C and these kind of, it was unclear exactly what we all individually had to do. We've now really anchored our ambition around net zero emissions, but also a timeline. So I think that's terrific. The problem with the approach is that it's all about ambition, right? And what's lacking is a kind of a robust plan which we can follow, like a roadmap that shows us exactly what we've got to build, where and when that's going to actually get us there. And, these ambitions are really informed by pretty high level course models. So integrated assessment models, some national level energy system models. And what they largely do is minimize the cost of the transition. Now, cost minimization is just one of the criteria that we're interested in, right? There's a whole bunch of other uncertainties that cost minimization models simply don't take into account. So, for example, what's the public's reaction to certain technologies? You'll see high electrification scenarios in which we achieve 100% sales of electric vehicles by 2040 or 2050. That may or may not happen, right? It's just unclear what the public's capacity to take on these new technologies will be, whether the public will accept things like nuclear and CCS. So there's a kind of a missing piece here, which is recognizing that pathways are uncertain and that a simple cost minimization is inadequate. Now, to solve that problem, you've got to get really granular. Now, the only example I can give where we've made an attempt at this is at Princeton. We just completed late last year a Net Zero America study, which was kind of the first attempt to say, in an economy-wide net zero transition, we went about, for every sector, spatially and temporally siting every asset that needed to be built, whether that's a power generation facility, a fuels production plant, an electric charging station, a transmission line, a CO2 pipeline, etc. And when you get that, now the trouble is this is really labour intensive. It was 15 person years of work. But when you do that and when you start overlaying the sort of traditional siting exclusions like social and environmental values, it is astounding the scale and pace of change we're talking about. So for the US, net zero in one of the scenarios, which was the most balanced, sees 1.5 terawatts of new wind, 1.5 terawatts of new solar, 3.5 times the transmission infrastructure that we have today, 1 billion tonnes a year of CO2 being sequestered in 2050, 1,000 new bioenergy plants, 60 million tonnes of hydrogen. And this is not or, this is and. All of these things have to happen in 30 years. And so, those high level models that have been informing these ambitions simply don't give us that level of insight. Now, I think every country needs to do this. And I think the other thing we need to consider is you know, whether we're Australia or Canada, we are acting in the context of what everybody else is doing. And so this points to some of where this discussion might go today is I think we're going to face really serious supply chain constraints. You know, the US might have to build 3 terawatts of wind and solar, but China will have to do more than that, and Europe will be doing their piece, and we're trying to compete in this kind of global transition. So I think, you know, we need much more granular insights into how we're going to get there if we're going to make this a viable transition. Now, we have such a project plan for Australia. We've started it. UQ is kind of leading that, and Princeton is collaborating. So that will be terrific to see the outcome. I think there are some unique features of Canada and Australia too, which we should consider. We're both net exporters of energy. In the US, we're essentially producing and supplying in balance, producing and consuming in balance. But Australia, for example, exports 3/4 of its primary energy. And so in a global net zero transition, we have to have a plan for substituting those carbon intensive fossil fuel exports with some kind of low carbon economic alternative. And so, you know, I think that's a lot of really interesting challenges. I like the grounding the ambition, but much more work needs to be done to sort of ground it in the realities of the execution challenge.
Thank you very much, Chris. That's really sobering in many ways. And I wonder if, you know, this buzzword that we hear a lot in government plans, this green recovery, may be illustrative of a much broader challenge related to the need for a new model, a new economic model, not only economic, but social, and a model for social and human development. What strategies do you think are needed to minimize social injustice in the transition to a net zero emissions future?
Yeah, Walter, that's a great question. And I think it's kind of at the center of whether we can get the job done or not in the timeframes we're talking about. I think the historical approach of developing projects on a project by project basis where developers are kind of responsible for securing public acceptance, you know, I think this is just not a suitable model for the scale and cumulative impacts of what we have ahead of us. And I think unless we can have some form of new energy transition governance approach where, you know, citizens are placed at the center of siting decisions, then I think we're destined to fail. So I think there's 2 risks we face with the existing model. One is the risk that we fall short of our ambition to reach net zero, but also the risk that we are left with a nation which is burdened by social injustices and environmental impacts that were perhaps unintended, but are a significant cost for the future. So you know, I don't think the model exists today. I think we have to find a model in which, you know, project developers, governments, financiers, local communities are part of a coalition. And this would have to operate nationally as well as at a state level and as well as at a community level. And I think these kind of coalitions will be necessary to ensure, A, we maximize our prospects of meeting our energy transition outcome, and B, we do so in a way which is minimizing social injustices and minimizing adverse environmental consequences. And I'm hoping the panelists who are much more engaged in that area of research can help us with that.
Thank you very much, Chris. And for those in the audience, you know, you can start putting some of your questions to the panel as we go, and we will collect those, and there will be an opportunity for those questions to be answered. But I want to move now on to Professor Rick Valenta. And this is one of my favorite topics as an energy person, because you know, every time I hear an announcement about a wind or solar project, we often hear about how many homes could be serviced by the new plant and the new generating capacity. but we seldom hear about capacity factors, or operations during cloudy or windless days. And in the same way, we don't hear about how many trucks or large vehicles could be powered by that same electricity generating plant. And I think the public and the media use the terms electricity and energy interchangeably, and seldom address the order of magnitude, sometimes differences that we have in demand associated with chemical, transportation, and electrical services of different natures. We have also heard plans of millions of electric vehicles and the associated recharging infrastructure to be deployed in the next few years. But there is no mention of the amount of copper, for example, that will be required to enable that transition. So I would like to ask Rick, if you could give us a sense of the magnitude or the scale of the challenge associated with delivering critical minerals for the energy transition. Rick, I think you're muted, sorry. That should be the other tagline, Diana.
There we go. Now am I unmuted? Can you hear me? Can you hear me all right? Good. Yeah, so we can look at that in a few different ways. First you could say, well, what commodities do we need to accomplish the clean energy transition? And I'm not going to list them all, but I think a lot of the audience would have heard about things like rare earth elements, a great increase in those, cobalt, lithium, nickel, and so on. But there are others that are sort of more traditional, but equally or even more vital, things like copper and aluminium and iron. And then you could ask the question, well, how much does that supply have to grow? And again, if you look at lithium in particular, but rare earth elements, cobalt, nickel to a slightly lesser extent, the answer is a lot. Up to 10 times what the current supply is. And then if you say, well, yes, copper, aluminium, iron have to grow, they don't grow so much compared to the current level of consumption, but they actually account for most of the extra tons of rock because because the existing volume of copper supply is so large already. So the overall trend, really, if you look at almost anybody who predicts this sort of thing, is for huge demand growth in a lot of these commodities. And the current estimates, if anything, are low. And I think the reason for that is that as we identify new technologies, what happens is that suddenly, somebody recalibrates the demand for that particular commodity. And the example of that's happening right now or starting to happen in an increasing level is vanadium, where people have identified a new form of battery that could be good for very large storage called a vanadium flow battery, a redox flow battery. And they look like they could drive a huge demand increase in vanadium that we don't know about right now. And of course, what we have operating at the same time is an increase in demand growth that's simply due to continuing increase in population. And of course, the need to try to meet the sustainable development goals, things like alleviation of poverty, giving the other 7 billion people on the planet the stuff that we already have, or trying to get them closer to what we have. And so in the case of copper, when you look at that and combine that with other factors, what we're seeing is that the production net of recycling up to 2050 is going to be about double of what it is now. By 2050, it'll be double. And when you combine that with decreasing grades, what that means is that in the first 50 years of this century, we will have produced 9 times as much tailings, which have been in the news for all the wrong reasons in the last little while, as we did in the entire 20th century. And that also applies to some of the other major commodities, all of which are projected to double. So those will create their own environmental problems. But the next question you might ask is, well, is the supply that we need to accomplish all this available? And there is a short answer, and that answer is yes. In almost every case, we know about the supply. And if you take lithium, that's one of the biggest growth commodities. If you take it out to 2050 predicted levels, we've got 400 years worth of lithium. So we're not going to run out of lithium. If you look at cobalt, we've got 80 years of supply on land, another 160 or so under the ocean that we know about. If you look at rare earths, we got plenty. The problem there is more around geopolitical risk. But the question is not and Chris alluded to this as well, the question is not, do we know about these deposits? The question is, can we mine them? Because the problem isn't technical. We know how to mine them. The problem is social and environment. We know where the supply is, but our current practices and technologies are really going to have to change for us to gain the permission that we need to get access to and produce those resources. And so I agree entirely that a new model is required. And you know, people, you often, when you're talking to people about this, they say, well, why don't we just recycle? Can't we recycle? And recycling is definitely projected to increase, but it's not projected to increase as fast as demand. And copper recycling currently accounts for about 20%. And yes, it's going to increase, but demand is increasing even faster. And recycling has its own economic and environment, social, and governance challenges. So they're clearly important part of areas of work, in addition to the sort of understanding and initiatives that we're discussing in order to achieve the supplies we need. But recycling and reduced consumption alone will not accomplish the clean energy transition. There's going to have to be a major increase in supply of all the metals that we need.
Thank you very much, Rick. And that number you just quoted really blew me away when I first heard it. You know, in the first 50 years of the century, we'll produce 9 times the amount of tailings that we produced in an entire century. That's a sobering number indeed. So you talked about the challenge being more about the social and environmental impacts of the extraction rather than just technologies or supply. And I would like to ask you, what the balance between government and private sector investment on clean energy varies globally, and some countries, you know, have a balance on one side as opposed to others. Can you illustrate how the industrial sector in Australia is embracing the energy transition?
Sure. Well, the first thing to say is that Australia also had its own announcement of a new clean energy initiative today. I think the government announced approximately $540 million initiative focused entirely on carbon capture and storage and additional hydrogen generation. So I guess technological solutions, which has really been their focus. But what I'd like to focus on in this is really the industry that I'm most familiar with, and one that accounts for a sizable proportion of Australia's emissions, and even more if you track their exports, which is the mining industry. And to say, well, you know, what issues, what initiatives are being undertaken by the mining industry right now to I guess address what they need to do to meet the clean energy or embrace the clean energy transition. And the first thing to say is that almost all of the major mining companies with substantial Australian assets, and I'm talking about groups like BHP, Rio Tinto, Glencore, Newcrest, etc., they've taken on a net zero emissions target by 2050. Anglo has upped the ante and made a net zero emissions commitment by 2040. And FMG, who's a major iron ore miner, has actually said that they'll try to reach net zero by 2030. And almost all have embraced approximately 30% emissions reduction target by 2030, though the benchmark year against which they're measuring changes from group to group. Even more interestingly, Rio Tinto recently, the board and management of Rio Tinto backed an activist shareholder resolution that was going to be put up in their May annual general meeting to actually make their emissions reduction targets more ambitious and to withdraw from any industry organization that doesn't fully embrace the clean energy transition. So they're actually, you know, they took an activist resolution, said, "Yep, we'll sign us up." And the other thing that's illustrative of to me is that it's really investor activism that's driving a lot of this change. You know, big investors can really focus the mind of companies more so than almost any other group. And you know, another illustration of that, of the level to which companies are taking this seriously, is that, you know, BHP has linked 10% of their senior executive remuneration now to climate change performance. So they're they're really focusing on things that are dear to the heart of their teams. And a cynic might then say, well, yeah, they're saying all the right things, but what are they actually going to do to accomplish what they've undertaken to accomplish? And they're doing that in a few different ways. One is, we're seeing companies change their commodity mix. So Rio Tinto has essentially exited from coal. When you look at I guess communications from a lot of the companies, they're backpedaling on the more emissions intensive parts of their portfolio, groups like BHP. And then when you actually look at what they're doing for sites, there's really two major areas. One is power generation. And I won't say too much about that because I think Ali is going to spend quite a bit of time talking about this, but there's a big transition going on to solar gas, where possible, hydro, and so on. And the other plank is around decarbonization of their mining fleet. So, and any of the sort of major copper, coal, any big mining operation, anytime you visit there, you see these 240-ton trucks or bigger that are running on diesel power, and they account for a huge proportion of the site's emissions. And so they're trying to decarbonate, remove the diesel from the equation by changing it to diesel electric, or then going to trolley assist, where well-trodden areas like the inclines coming up and out of pits become like trams, where they can electrify them and help them move up, and so on. And then the other area that I think is going to be really important for any of these companies to achieve their targets is through offsets. So we're seeing a growing interest and emphasis on mineral carbonation, where they take CO2 and combine it with magnesium-bearing minerals or waste products and fix the CO2 in minerals. And BHP's Mount Keith operation is an example of that, where they're making a hydrated magnesium carbonate mineral and fixing CO2, or carbon capture and storage. The various schemes like blue carbon, etc. I won't go through them all. And of course, also buying swaps, which is possible under the Paris Agreement. But the thing that we're finding is that we don't deal. My group doesn't deal too much with the people in charge of climate change within these companies. What we deal with is the technical people, the geologists, the mining engineers, the mineral processing people. And the message we're hearing from those people is that issue is now front of mind in all these companies. They're asking themselves and us, what we've been tasked with is how to simultaneously maintain productivity, hit the company's emissions targets, and improve our environmental and social performance at the same time. So it's an enormous task, but it's really something that Australian companies will set their mind to.
That's fascinating, Rick. And there's already some questions from the audience. I see that. I mean, there's so many important questions. It's interesting that you say that Australia just announced today, because yesterday Canada, of course, made a similar announcement, and it's 7 billion Canadian dollars over 7 years for the hydrogen carbon capture and sequestration. So I think there's plenty of opportunity for Canada and Australia to work together in some of these areas, and I think that will come up later in the discussion. Thank you. So I will move now, just in the interest of time, to the next panelist, and then we'll start the questions at the end of this first round. And the next panelist on my list is Dr. Ali Madise. And Ali, I'm trying to look at what Canada, in relation to other countries. So for example, Canada and the US have signed the Joint Action Plan on Critical Mineral Collaborations, which is going to advance the reliable supply of critical minerals on both sides of the border. The governor of Saskatchewan recently announced a $31 million investment in a rare earth processing facility. And many of these initiatives require significant and sustained investments over 3 or more decades. So in that context of these, big decisions that governments are making, can you tell us a little bit about the current status of the Canadian mining sector and challenges and opportunities that the energy transition may reveal for that sector?
Sure, yeah, thank you. And thank you all the panelists at some of the numbers that were exchanged. are quite interesting with respect to our discussions. Well, let me begin with the Canadian mining industry with which I'm more familiar, but I think the numbers resonate with all the people from Australia and also as well in the world. Well, what we call mining, we have to admit, it's a very broad set of activities. So mines are really diverse in terms of the types of energies that they need and also the amounts of energies that they need. So when we look at mining in Canada, depending on the type of minerals that you're mining, the type of the mine itself, the design of the mine, whether it's surface or underground, the type of rock that you're dealing with, is it a soft rock, hard rock, the climate, when you go from Arctic to mildly cold all the way to hot environments. And quite surprisingly, in some cases in Canada, we have a very cold winter and a relatively warm summer. So we have the both ends of the extremes. And also the logistics, you have access to roads, what kind of transportation you're dealing with, loading and offloading facilities, complex terrains that you're dealing with. So these are all factors that play in and set the bar for how much energy and what type of energies you need. And in the end, I would say grid access is a very important factor. So if you're dealing with a remote location that doesn't have access to grid, so power lines and also natural gas pipelines, it makes it very complex and very challenging. And I give you an example, some of our diamond mines in Northwestern Territories, they need somewhere between 50 to 100 million liters per year just to run the mine. And they use diesel for everything. You go from power, so electricity, all the way to haulage and trucks and materials handling, and also heat. So these are the challenges that mining industry is dealing with. And I would say with all that, and given the standard that the industry has to meet, you are running a very complex chain of like mining processes. You're excavating, running comminution, very large plants on the surface, beneficiation, all the chemical processes that you have, and then you have to be very safe and also cost effective. Productivity shouldn't be disrupted, so on and so forth. All these constraints have made it very challenging for mining industry to move away from carbon-based energy. And I'm talking about as a whole. So we have to look at it and then understanding all those challenges, see what has been done. I would say there are some very good examples in Canada. We have one of the first examples in the world, Diavik mine, that used wind turbines for to offset some of its diesel consumption and diesel power with wind. We have Rugland, which followed suit, and these are two very two good examples. We have some mines in Canada in the 40 and 50 years ago that used thermal storage, seasonal thermal storage solutions that help them with saving energy on heating and cooling. These are all very good examples using renewable energies to offset some of the emissions on the mine, help the mine with offsetting its carbon, so on and so forth. But when we look at it, the challenge is you need electricity, motive power, and thermal power at very high, so we have very energy intensive, and decarbonization and moving away from fossil fuels is the challenge. So you have to transform not only the way you generate power, which I would say is the lowest hanging fruit, you have to transform also your materials handling. So Rick talked about the trolley assist, railway, conveyor, rope cons, battery electric, hydrogen trucks. These are different solutions, but which one are you going to take? Is the supply and chain and the maintenance services, everything, all the risks that are associated with it. Are the OEMs ready to provide you with all your fleets? These are all the challenges. So in my own experience, I cannot emphasize enough the importance of carrying out proper due diligence. So looking at hybridization options and choices that you have at your mine site, and also looking at it from the system level, and then basically downcasting it to every detail, like the electricity and motive and cooling or heating power that you need at your mine site. And also understanding, because of the diversity, There is no single solution. It's not a one-size-fits-all solution, and there is no silver bullet. So it has to be looked at it from a holistic point of view, and the solution can be worked out. So, but there is hope in the end of the tunnel as well. The research is showing that in most cases, renewable-based and decarbonized power it can be cost-effective. So the net present costs are going to beat the fossil-based solution, and also the payback periods could be decent should you invest into it and also basically develop the project with the knowledge that you're going to go for clean technologies, so on and so forth. So with that, there are some Canadian mining companies that are really progressive. Like I'm working with big names in my own research. Like I can give you some examples, like De Beers is working very progressively and ambitiously there. And there are some engineering firms that are doing a good job in helping them developing these projects. So
I'm going to put you in a little bit of a tight spot, Ali, and I think
sure.
you know your comments about the due diligence and how specific you need to get, and touch, I think, a little bit on what Chris said at the beginning about how granular you need to get in this kinds of analysis. I mean, this is applied to a sector, but Chris was talking about the regional, perhaps, or national analysis, but it's the same challenge. So if you had a crystal ball, could you make some forecasts of predictions for the decarbonization of the Canadian mining sector in the next 2 or 3 decades?
Yeah, as Yogi Berra said, it's tough to make predictions, especially about the future. So with that, I would refrain as much as I can from making predictions. But I would say, looking at the status quo, there are some good solutions out there. Renewables, hybridization of renewables, and the challenge is not generation. It's over the past 2-3 decades, the cost of generating renewable energy, being it solar, wind, it has dropped quite significantly. The challenge is in storage, and storage needs very large battery sizes. So these are heavy investments that you would need. And also, so far it has been like the norm, but in mining you have maybe an opportunity, and that is if you have hydrogen fleet that can use hydrogen generated at mine site. So hydrogen storage can help you with that, but it is a very complex scenario that you're creating. Suddenly you are not only running a mine, you're also running a hydrogen plant, which comes with all the key factors that play it safe would bring with itself. So we should really look at it from the challenges of, it's not a turnkey solution that you're offering to a mine. You're basically moving them from what they are used to, and that is minerals industry, all to very complex problems like generating hydrogen at your mine site, storing it at your mine site. And then it is a collective effort. It cannot be done only by mining industry and mining sector. It has to be done by government support, a lot of support from R&D, from OEM, so on and so forth, to make it work. But if I were to go to make predictions, I would say it's a step-by-step transformation. It doesn't happen overnight. Right now, what we've done when we look at the projects that have been worked out, the penetration of renewables is only, and that is only for the power, which is less than half of your total energy, is less than 10 to 15%. So if you want to achieve 90% of your power in renewable, you have to transform the design of the system, and it's happening step by step. So maybe in 5-10 years, we will have 50% of our power through renewables, and then we can make a bigger leap and arrive at a much lower, carbon emitting means of generating power and also moving the ore, so on and so forth.
Thanks, Ali. I think that's a great segue. You mentioned how mining is really a very broad sector that touches on, grid access and transmission and so on. And I think, Nadia, this is a great segue into perhaps the questions I would like to ask you, because obviously many of the challenges that have been exacerbated during the pandemic are by definition global and multidisciplinary. And facing those challenges will require an unprecedented, I think, level of coordination, collaboration, and transparency. So given that context, what does the new global normal mean in terms of water management in the resource sector, which is another big challenge for mining and other sectors?
Yeah, thanks a lot, Walter. And I think I remember when we were preparing for this panel, we were reflecting as a group that we're so used to seeing these exponential curves with the pandemic. And when we think about some of the numbers that Rick quoted earlier, it's unfortunately quite a similar picture in terms of what things look like for future mineral supply needed for this transition. And so, you know, for me, the question I am, you know, reflecting on a lot in this dialogue is, you know, what does that mean in terms of kind of the social and environmental impacts that will come as a result of this rapid growth in mineral supply. And as you mentioned, Walter, you know, my area of interest in particular is around water management within the resources sector. And so for me, this rapid change that's happening in demand for minerals is really driving me to you know, to think a lot about what these implications will be for water issues. So I wanted to kind of dive a bit deeper into why water and mining is an important space, and then I know we'll broaden out a little bit more later on around what collaboration can look like. But, you know, when we think about water use by the mining sector at a national or a global scale, it's typically a very small user of water. So in Australia, for example, you know, mining accounts for around 4% of national water consumption. But if you dive down to a local level, the impacts become much greater. So the state of Western Australia, it's around 25% of the state's consumption is associated with mining water use. And so, you know, I guess the message there is that water impacts are often clustered close to mining activity. And so this is important because when we think about the rapid transition of rapid growth of the mineral sector, you know, there's estimates from the investment community that, you know, 2/3 of the world's largest mines right now are in areas that are already very water stressed. So if we think about the expansion of the sector, you know, that raises concern around just intensifying those conflicts that mining may already have with surrounding water users around getting access to water that we need to run mining projects. There are also lots of mines that are in areas that have an abundance of water, so they have too much water. And you know, yeah, as you'll tell from my accent, I grew up in Queensland. You know, the Bowen Basin mining region back in 2010 had major flooding events that cost billions of dollars and also raised a lot of concerns around environmental impacts. Rick spoke as well about significant challenges around tailings. So to think about the sector expanding and what that means for tailings are very significant. So it was just a couple of years ago that there was a significant tailings dam disaster in Brazil, the Brumadinho failure, which caused 270 deaths and a lot of environmental impacts as well. And unfortunately, we've had also catastrophic tailings dams in Canada, such as the Mount Polley mine, which also raised a lot of concern for First Nations communities. And so, you know, water issues are often very much a concern for local communities, and the legacy effects of those issues are also very significant. So it's not just when the mine is operating, we might have challenges around access to water, or the industry, I should say, may have challenges around access to water and discharge of water and what that means environmentally. But also when we close mining sites, very often water issues are one of the biggest challenges that we have in terms of managing legacy impacts. And so one mine that I've been doing some research on here in Canada is the Faro mine in the Yukon. It operated for a period of around 30 years from 1969, and you know, it was once one of the largest lead zinc mines in the world, and now it represents, you know, one of the largest challenges for cleanup projects in the country. And so, you know, the amount of waste that's left there and the potential impacts of that waste in terms of the water contamination that can happen, that can result as a result of that waste, can be really significant, and cost estimates in, you know, $500 million to clean that up. So what this all means for the future in terms of, you know, how are we going to manage these impacts going forward? Because you know, the projections suggest that these impacts are only going to get more difficult. We're going to have to mine lower ore grades, as Rick mentioned. This means we have to dig a lot more rock out of the ground to get the valuable material we want, which means more tailings. It means more waste. It also means actually that other estimates have shown that as we mine lower grade ore bodies, we also need more water and energy per ton of product that we produce, because we need to dig up more rock, and as a result, we actually use more water and energy. So without doing things differently in terms of the way we innovate in the sector, both in the mine site, but also in the way where the sector is collaborating with communities and other rights holders beyond the mining fence, I think we're going to be in trouble. So the future needs to be different. Absolutely, I think is the message that I would say. Back to you, Walter.
Thank you very much, Nadia. And this is very fortunate that you were in Australia, of course, before, and now we have you here in Vancouver. So you are perhaps one of the best persons to tell us, or to illustrate perhaps existing collaboration mechanisms, or discuss what new mechanisms would be needed for an effective and accelerated innovation across the Pacific. Yeah, well, I appreciate I've outlined a pretty gloomy picture, and I think from listening to all the panelists today, it's we do need more collaboration. I think the message I want to send is that these challenges are really complex, and when we have these challenges that are so complex, we do need to work collaboratively to solve them. So I'm very lucky here at UBC because I work across two different departments, between a policy school and a mining engineering school, and I also have links as a faculty associate to the Institute for Resources, Environment and Sustainability here at UBC. So I'm very privileged that I'm able to integrate and collaborate with different researchers across disciplines, and I think this is really what we need. I think we also need to learn from other countries, to exchange experiences between Canada and Australia and with elsewhere in the world. It's helpful to look at what worked in another place and to be able to reflect on what that can mean at a national scale as well. So in my own research, we've been certainly aiming to develop lots of collaborations in different ways. Right now, we're focusing very much, within my kind of scope of work within the water space. We've been developing partnerships with a range of different actors. So, companies, government departments, investors, and First Nations right holders. And the reason that we're doing that is that I think we need to really have all of those partnerships as being essential to come up with solutions that recognize the complexity of the problems, and also what that can mean in terms of what's practically feasible to solve them. So for the last 6 months, I've been leading some strategic planning activities at UBC under the Bradshaw Research Initiative on mining. And so as part of that, we've been convening events that have brought together different kinds of actors from the different areas that I mentioned, to kind of understand better what are the challenges from the policy perspective, from the company perspective, from rights holders, and how can we go about solving them. And I don't want to pretend that we've come up with a solution, but I do think that as researchers, our ability to engage proactively with these different groups is absolutely critical. On Monday, we had a really interesting workshop on understanding how to better monetize the risks that mining poses to water. And what I found very fascinating about that event, was that from any perspective of any of the kind of groups that we engaged with, that there was recognition that none of those groups could alone solve the challenges that we were putting on the table. And so it would only be through collaboration that we would be able to get a better approach to understanding how to better integrate those externalities into the way we develop mining projects. And so we were focusing in particular on how do we assess the costs and the risks around water on communities and on the environment. And those
one of the biggest challenges in assessing those costs is that often those long-term liabilities might fall to a range of different actors, and it's not necessarily the company that is responsible for dealing with or responding to those costs in the long term. We also have changes in our scientific understanding over time. So, you know, water-related pollution issues that exist today, and I can talk through some examples in, you know, in the Q&A if desired, but, you know, we didn't know about those problems the way that we know about them today. You know, we didn't know how bad they would be 50 years ago. So our scientific understanding of pollution issues is also evolving over time. So I think, you know, I came away from that workshop we had on Monday thinking that, you know, we need to start thinking about how we can design projects to be more adaptive, you know, to be able to make better decisions throughout the life of mine, and also create spaces where we can have more collaboration between different areas of academia, because sometimes we're siloed within the university, but also to bring together different parts of society and government industry into the same room, because I think that is crucial for the very complex beast that we have ahead of us.
Thank you very much, Nadia. I think that's great. We have gone all the way from the global challenge, you know, that Chris identified, the need for a whole new economic and social development model, to the magnitude of the challenges in some specific supply chains, to a sectorial view from Ali, to now this really illuminating discussion on how many actors, you know, need to be involved. So with that in mind, I think it's a perfect segue into Diana's area of expertise, because Diana, you of course focus on the social impacts of mining. So in the context of that research area, I would like to ask you, what does the energy transition mean for a local community?
Thanks, Walter. And there's a lot to pick up on. I'll be reinforcing a couple of the points, particularly that Nadia made. But I'll focus initially on three things on the local community side, and mostly with a focus on the extraction of energy transition minerals. I'll shorten that to ETMs as I talk, and Rick listed some of those. So just, you know, that it's quite an inclusive term. So it does include copper, iron ore, aluminium, critical minerals, and also rare earths, so ETMs. And I'll talk first briefly about impact, location, where we're going to get all this from, and then just a quick touch point on regulation. So the first issue, social impact. We've heard so far that to support this big transition, the energy transition, that the pace and scale of mining is set to increase. So we really need to ask, what will that look like for local communities where all these resources are going to have to be extracted? So Rick explained how many new mines are going to be they're projected to be lower grade, deeper, with larger waste footprints. So this will place huge pressure on land. So we're going to start to see increased land use competition, especially in rural and remote communities. And land use competition is not a new problem in mining, but it's going to be more widespread as we ramp up the production of ETMs. And as production ramps up, there's not going to only be competition for land, we're also going to see competition for other resources. And Nadia spoke so well about water. So too little means we're going to see competition between users, and too much means that waste is going to be difficult to contain, which can lead to those unacceptable impacts on land, water, and people. And we know that when miners kind of rush to meet this demand, that social impacts are often overlooked, the studies aren't done properly, and communities get short shrift. So at the pace and scale that we're looking at, mining would absolutely need to be done differently to give people confidence that impacts are going to be studied, mitigated, and managed. And if not, you know, we're likely to see opposition to energy transition minerals on quite a grand scale. The second issue I'd raise is sensitive locations. So we need to think about where this ramp up is going to take place. And again, Nadia touched on this, but to meet projected demand, it looks like the industry is going to have to be building new mines in sensitive locations, more sensitive locations in Australia and Canada, and also elsewhere, as we also source what we need for the transition. So we're hearing more about the Arctic, the high Andes, the Atacama, and particularly a lot of discussion about the deep sea. So this is where many prospective projects are located. And these new projects are set to encroach further onto the lands of Indigenous peoples' territories, other land-connected peoples closer to biodiversity conservation areas, and potentially in, you know, quite politically fragile locations. So we may have a situation where we not only have more mines, but also more mines in more complex environments facing multiple risks. So that's the, I guess, the problem statement to engage with. So again, mining would have to be really done differently to give people greater confidence that impacts are either going to be avoided altogether, we just, you know, we don't mine in some of these locations, or much better managed under the circumstances that, you know, that we're looking for into the future. And this isn't kind of short-term social investment and donations off to the side. This is really serious management of social impacts at the operational level to avoid harm to local people and environments. And this third issue is regulation. So as we think about the ramp up in ETMs, I find myself asking, I think Chris put this provocation out to start us off, you know, will our regulatory systems actually be able to handle this? Are we gearing our governance mechanisms to be able to handle this? So states assess merit, project merit, on a project by project basis. So approvals bodies cannot assess the merit beyond the project that's on the table. That's how most of our laws are set up. So approval bodies can't take into account big projects coming down the line or what's come before or what's coming after. It's literally projects on the table. So regulating for cumulative impacts is already a big challenge for us. And it's going to be an even bigger one if we're looking at an ETM boom. And we must also remember that the uptick in ETMs is happening at the same time as we're seeing a wind back in fossil fuel industries. So if we don't find ways to plan for and manage the social impacts of both, you know, the ramp down in fossil fuel and also the ramp up, we'll face opposition on all fronts. And the energy transition itself could slow or stall. So, you know, this could be absolutely devastating for climate action and the strategies and the ambition that was, you know, kind of described at the beginning. So they're the three things that come to mind for me in terms of extracting energy transition minerals. Do we understand the social impacts that are coming down the line? Mining may be heading into even more sensitive locations, and questions about how our regulatory frameworks can better consider the cumulative impacts of all of this.
Thank you very much, Deanna. That's really a great thing, a great way of looking at this, actually, because in some cases, it's not the technologies are not the problem. It's really the rest of the system that is going to be a challenge. So we have focused for most of the discussion on the mining sector, but what about the renewable energy side? Do these same concerns apply to, say, solar or wind farms?
I would say yes. So many of these same concerns apply to wind, solar, and so forth. So many renewable projects have a large footprint. They're being brought online at that same pace and scale that we've not previously seen. So knowing that we'll be moving really quickly and knowing that regulatory systems are often slow to adapt, I think it's just important to highlight here that we must be listening to people who are potentially affected. So this is why deliberative processes of consultation and consent and collaboration, as Nadia flagged, are really vital, both in resource extraction, mineral resource extraction, and also in renewable projects. I often hear the term, you know, people often dismiss local opposition as NIMBYism. So there's this term, not in my backyard. NIMBY is an acronym. It's a really pejorative term. It's designed to kind of dismiss people's often quite genuine concerns that they have about their community, their family, or their land, their property, their cultural heritage. So the not in my backyard is often a signal that people do not agree with having industrial scale risk imposed upon them without having a say. And yes, there can be anti-mining and anti-development elements kind of bundled up with that, but usually it's not the majority. So I think we need to be careful not to dismiss people's genuine concerns about these otherwise clean and green and, you know, positive projects, because underlying that there's a lot to think about in terms of social impact. So Chris touched on this term, just transition, and I think that's a term that signals to us that we must get a lot better at listening to people's concerns and interrogating what the social impacts are going to be, whether they can be avoided or mitigated, and that's what's going to help us achieve a just transition. So we can't accept local harm for a greater good. This doesn't accord with the Paris Agreement, and it doesn't align with the UN Sustainable Development Goals that we're all, you know, kind of referencing now into the future. So if the energy transition is going to be successful, we do have to exhaust all options to avoid harm to people, whether extracting minerals or building, you know, really exciting new renewable energy projects.
And I think that's something that is often perhaps lost, certainly when these large renewable energy projects are deployed, that I think they will face some of the same challenges that other projects have faced in the past.
Yeah.
So I can only say how, you know, fascinating this is to me. I am an engineer, so, you know, looking at the other aspects of the energy transition is really fascinating and a huge challenge. I have now some really good questions from the audience, so I'm going to start asking them. I will start from the ones that were actually placed on the Q&A section. There is, I think, one directed specifically to Rick and Ali. Internal combustion and jet engines can be engineered to run on hydrogen, so why do we stick with diesel? And I don't know which one.
Walter, if Rick agrees, I can take that. In fact, that has been looked into. Thank you. So it has been looked into. It is a solution that mines are looking at, especially hydrogen turbine for power generation. It's not emission free. The same emissions that you get in terms of nitrogen oxide, which are basically hazardous for humans' health, are even at a higher level found in the combustion flue gas, like the exhaust of hydrogen-based internal engines that includes basically engines and turbines. But I would say that's a solution that industry is looking at, whether they can resolve the emissions issues or not. But regardless of that, you see, we have fuel cells that are at larger scale available at very good cost. So if you have the hydrogen locally generated and stored, using it whether in an internal combustion engine for power generation or for in a fuel cell for power generation is not the biggest challenge. The biggest challenge is generating and storage of hydrogen at a large scale as currently in terms of technology.
Yeah, I mean, I would just
go ahead, Rick, go ahead.
No, I was just going to say, I think the other more pragmatic reason that it hasn't been sort of embraced wholeheartedly is that it costs a lot of money for big diesel trucks. And, you know, when you got a mine going and you're just about to actually make your money back, or you're hoping to do so in the next 4 or 5 years, you know, when you say, okay, we're going to make another $2 billion investment in a whole pile of new trucks or retooling or anything like that, then it's a challenge. But I think that's why a lot of companies, or, you know, things I've seen where companies are sort of listing that as something that they're definitely keen on doing down the track, and they're piloting things. You know, Anglo is doing it. I've seen other companies who have announced that sort of thing. So it's definitely, there's no technological barrier to it. I think the barrier is more economic, and as Ali said, it's not, you know, perfect on it.
And this, I will just very quickly add that, you know, both Airbus and some other air manufacturers have announced plans for hydrogen planes by 2030. So the designs are on the table, and there is a company in the UK called Reaction Engines, I believe, which is working on a hydrogen engine specifically designed for hypersonic flight. So, you know, I think there is activity in other sectors perhaps that could be beneficial to the challenges in a mining operation. There is a second question from the audience, which I think is probably directed to Nadia and Diana. With such a gloomy outlook and large-scale challenge ahead, do you think that this entire energy economy social transition is truly achievable? What are some of the steps that must be taken immediately globally to meet this goal within a 30-year time frame?
I'm happy to kick off and you can pick up, Nadia. I like this question actually because it recognizes that it's not just an energy transition, it's a social transition. So I think that is becoming clearer to people, and a lot has to be credited to the introduction of and pickup of this term just transition, which is really an encouragement to attend to some of the downside effects. So it might be gloomy, but I don't actually take that as a negative thing. I think that's really starting to surface what we need to deal with. So I actually think a little bit of gloom to start us off to make sure we catch everything and then focus on what we need to do about it is actually, I see that as a little bit of gloom is quite positive. But it does say attend to the downside, attend to the human dimension, and also, you know, the rapid switch means rapid change, and we have to support people and communities through that. But a lot of people are starting to articulate what needs to be done, and there are groups that have been studying this. Say that, you know, there's a bit of a list of things, and I thought this question might come up. So, you know, we're encouraged to invest in transition technologies and innovation. So that's one thing we're seeing. Australia and Canada, the announcements that are made. Inclusive social dialogue and stakeholder engagement. That's another thing. Research on the use and effects of all this technological change, and that means social, environmental, and across the disciplines. Think about environmental and social protections. So we need to know, you know, where people might slip through the gaps and what we can do in order to offer protections. And plan ahead is really the main thing, which is why we're doing this seminar, to be, you know, kind of surfacing the things that we need to do with. Don't wait till a change is upon people. Think about economic diversification, skills development, redeployment, studies, so that we can understand as much as we possibly can to then build solutions. So there's a lot that is coming out that people can think about in that area. So I'll hand over to Nadia to finish off.
Thanks, Deanna. And I think, I mean, I agree with you. I think the recognition of it being a problem is actually the first step towards addressing it. And it actually loops back to one of the comments that Walter actually made right at the beginning, where he kind of highlighted some of the things that are sometimes missing in national policy discussions. And I think for me, that's also a key thing, is as we think about ramping up the mineral sector and the mining sector for the energy transition, making sure, or even going back to where Chris was framing us, you know, in terms of how significant this shift is going to be, recognizing that that's happening explicitly and planning for it, I think is really crucial. So making sure that those social and environmental impacts that are foreseen to accelerate are being adequately planned for, and that we have regulatory systems that are set up to do that. And I think, you know, this question also points to how interconnected our societies are. You know, we're, I think, you know, Chris was talking about, you know, Australia and Canada being, you know, net exporters of energy, and other places like the US importing more. So kind of understanding how dependent we are and reliant on other places and other, other people, and what those associated impacts look like. We are starting to see more material supply tracing in terms of where minerals are coming from, so that we're able to kind of accredit and understand, you know, when as we can do with some other products like coffee, you know, having fair trade coffee, you know, will we be seeing things like fair trade minerals in future and fair trade metals? That's something that I'm curious to see where that evolves. But I think we have to recognize that, you know, as consumers, we all are connected to this broad challenge, both in terms of our energy consumption and also the products that we use. And the role that mining has in that. So I think there's some of the immediate things that I think are starting to happen, but I think the short answer to that question is we have to transition. And so I think the question is just, how do we make sure that we do that, as a society with minimal impact.
Thank you very much, Nadia and Diana. I think, you know, that's it's just more and more I realize that the engineering challenges are the smallest challenges, and these other challenges are going to really be the main dialogue that needs to start. I have a question from the audience that I myself find very interesting, Chris, and I'm going to direct it at you because to start the conversation, because the question is, do you see artificial intelligence playing a role in our transition to net zero? If so, to what degree do you see it playing a role? And I think this is a little bit connected to what Nadia just alluded to, which was these fair trade metals. And I think, you know, in the hydrogen side, Ali, there is a huge discussion about the color of the hydrogen. So do you have gray, blue, or green hydrogen? And I think eventually what we will come up with is some sort of carbon intensive metric that may become part of a brand. The European Union has already announced they're going to have carbon, I can't remember the term they use, but it's some sort of carbon adjustment price for cement and other things coming into the European Union depending on the carbon intensity. So I think it's starting to happen. So Rick, and maybe Rick and Chris, maybe you can start the conversation about the role of artificial intelligence as a proxy for a broader computerized way of looking at tracing some of these carbon footprints across the supply chain.
I'm happy to start. I'd probably take it up a level and I think focus on digitisation more generally. And I think it's much broader than just tracing and tracking the carbon intensity of materials. So if we think about all of the projects that have to be built, so the terawatts and terawatts of wind and solar, and all of the mining projects that have to feed that sort of supply chain, then, you know, and we've talked about the need for new models of community engagement, then I think one thing we're going to need to improve community engagement is a kind of a visualization of what the future holds for communities and for society more generally. So I think digitisation can help in that kind of making it much more clear to the communities in which we're engaged. I think also when we think about the scale of projects and the number of projects that have to happen, then, you know, we've talked about how we want to do everything so much faster than we've done before. You know, we've never built projects at the scale that is envisaged in a net zero future. And so digitisation is going to have a big role in the way we design projects, the way we execute them. And then on just the way we consume and use energy, we're now going to have a much more significant role for weather-dependent energy sources, and likely a much more, I think, variable response on the demand side as people's behaviour begins to change. And so artificial intelligence can help us, I think, much better match supply and demand. And then, as you say, we're going to become increasingly sensitive. So people who are the fast movers on decarbonisation are going to be paying a price, and they need to be somehow protected against carbon intensive products competing with their own. And so this kind of some sort of blockchain approach to attaching a kind of a sustainability metric to every product we buy, I can see that becoming quite an interesting part of it. So, you know, I think one of the things that we just discussed with Nadia was, you know, how plausible is this very rapid transition? And I think if we think about business as usual, the answer is it's pretty tough. But if we think about kind of digitisation and some of these really fast-moving enabling technologies, then, you know, I think we've got a better chance of delivering on all the metrics: the technology, the cost, the social engagement. And so I've got a lot of hope for digitisation as being a critical enabler.
Well, I'm okay. I'm not muted.
Yes, you're okay.
I'll go a little bit more granular than Chris on the artificial intelligence question, in the sense that in mining now, the way, you know, part of the reason that's got us to the current, or part of the set of factors that have got us to the current situation is that, you know, we've driven down mining costs by driving up economies of scale. So a flotation tank, in, you know, when they were first you know, invented, they were the size of a washing machine, and now they're the size of an Olympic swimming pool. You know, everything has become enormous. Comminution, you know, big grinding mills, everything's become enormous. And the way it's getting around that, we've been mining like a, you know, like a whale. We just take an enormous gulp of the earth and then spit out the bits we don't want into an enormous risky tailings dam. And that's what you do when you have no control over the variability in the actual rock, and you have no control over how the mill deals with different bits of ore, and you don't know which bits of ore you're dealing with when. And artificial intelligence and the better sensing technologies we have now are the key to developing a much better understanding of the rock that we're mining, that will allow us to make enormous, you know, efficiency gains and make progress towards reduction in you know, emissions just through efficiencies at the processing stage and allow us to produce more metal per bit of emission and produce less tailings. So you know, artificial intelligence has the ability, and a lot of mining companies are well onto this, has the ability to turn mines into intelligent mines that can accomplish, you know, a lot of emissions reduction simply through efficiencies that it affords. So it's a you know, it's a very important component, I think, of this transition.
Thank you very much, Rick. And I think the next question is directed to Diana. Professor Camp, to meet the goals of the Paris Agreement, research estimates that Australia must leave 90% of its coal resources in the ground. Do you think that such drastic action is a possibility for Australia? And if so, how could we achieve this?
I don't know whether anyone else has heard that particular figure, but Chris, are you? I might actually flip that one to Chris in terms of percent of coal left in the ground. I know it's being debated. It's very important to talk about the social dimensions of that. But perhaps, do you want to pick that one up, Chris?
Look, I'm happy to. I think this is the unburnable carbon debate. If we're going to stay within 1.5 degrees C, we've got a limited amount of carbon we can burn. Coal's the most carbon intensive of the fuels. And Australia has large resources, as do China and the US and others. Look, I mean, this is part of the social justice issue, right? I mean, I think if you're going to stay within 1.5 degrees C, and if we can't make carbon capture work at enormous scales globally, then that does mean we leave a lot of coal in the ground. And so I think that's potentially inevitable, but it means we have to then make sure the communities who rely on, you know, coal mining for their livelihoods and so forth, we have to make sure they are able to transition at the same time. You know, the political economy of coal, that's a separate question. I think everybody recognises this is going to be pretty tough to achieve in Australia, but I think it's going to be necessary if we want to be facing up to a world which avoids exceeding 1.5 degrees C of warming.
Great. Anyone else wants to add anything? We have lots of questions, so it's actually, I'm not sure we are going to get through them all. There is one that is kind of topical right now, given some of the announcements that have been made in Canada, especially. The question is from Grant Chalmers, and the question is, nuclear energy will be critical for any sustainable transition to net zero in 2050. Does the panel have any information or thoughts on the Canadian small modular reactor roadmap? I think that's a very specific question for the Canadians in the room. But I think it's just a broader question of the role of nuclear energy in the energy transition. So if anyone wants to start the...
Sure. I think if you can hear me, Walter, can you hear me? Okay.
Yes.
I think myself and Nadia can take this. I should add here that Nadia just almost a year ago published a paper on this, and I've been following the subject closely because it affects my research quite significantly. I do agree that within, let's divide the future in short-term and long-term transitions, right? I think SMRs and the small modular nuclear reactors would play a role in the longer term relative, right? When we look at now to 10 years from now or now to 20 years from now, the stuff that are pretty mature on the pipeline of R&D are the ones that OEMs will mass produce and miners will have at their disposal. So when you look at SMRs, they are still under development. There's a lot of investment that was announced recently from the government of Canada, especially. A lot of research money is going to be devoted to that. But I don't think you would see a mine in the near future, let's say 5 or 10 years from now, that will have would be running SMRs. Even if it does, you're just producing electricity. You're not going to basically remove the emissions associated with a remote mine that 60 to 70% of its emissions are related to materials handling, being a diesel, and the rest is heat. So I would say I look at it as a very good solution if they're de-risking. So you could see, then if you bring an SMR to a mine site, you are basically creating a potential for a nuclear disaster, right? So you have to be very sure that the risk is very low. Even if it happens, there are ways to contain it, so on and so forth. You don't want to have a Fukushima reactor leakage on every mine site. We already have a lot of licensing issues dumping tailings on a mine site. Forget about the radioactive contamination. So I would say in the longer term, if it develops good and confident, reliable processes and good economics, because right now the LCOE, levelized cost of energy production or generation, with SMRs are still very high. If these issues are resolved, yes, maybe from 2050 forwards, you can use it. But right now, I don't see any mine taking that as an option. Nadia?
Yeah, I'll just make a quick comment, and then I think Rick and Chris might want to jump in as well. But Ali mentions a study that I did with my colleague Romana and Sarah Froze here at the policy school. So we were looking at the opportunity for small modular reactors in remote regions. So when we think of remote regions of Canada, they're kind of the most attractive for rolling out SMRs. And so we specifically looked at remote mines and also remote communities, and looked at the levelized cost of energy in those locations to see how feasible it would be. And yeah, the long story short is that study found that it's not as economic as the alternatives that exist for other forms of energy supply, including in particular renewables are becoming much more competitive in those areas. So I think I think that in the context of the work we did, we found it wasn't competitive right now. Whether it has a role in the future, I might divert to my other panelists, Chris and Rick, to jump in.
So I guess the first comment I'd make is I'd be careful about comparing technologies on the basis of a levelized cost of electricity. Wind and solar are weather dependent, so they're not always available on demand. And so it doesn't matter how cheap they are, you need some what we call firm generation, always in the mix to some level. I mean, nuclear, small modular reactors are one of the options for that, natural gas with CCS, hydro, bioenergy. And so Canada's kind of blessed with all that hydro, and you may be able to get away without nuclear as a firm generation source. The study we did in the US, we found that 4 out of the 5 scenarios, we needed some nuclear. And it ranged from 40 gigawatts in a, 2,000 gigawatt system, all the way up to around 20% of the mix if we had serious constraints on renewables. So, I see nuclear as having real option value. I mean, it's nice to have that there as a viable, commercially sensible backup, but it isn't going to be required, and it's in every location, and it's not going to compete in every location. But I think, I think I'd be hesitant to take it off the table just yet, and so I would encourage people like Canada and Australia. It's obviously legally prohibited, but I would encourage keeping the option on the table, and if that means investing in a roadmap to make it a genuinely real commercial option, then I think that's a good strategy.
Well, thank you very much. Sorry, go ahead, Rick. Sorry, go ahead.
I was just going to say, I'll only add I'll take my UQ hat off and put on my Canadian mining industry in my previous life hat, trying to get a uranium mine permitted, failing at the first hurdle, that everything associated with uranium and nuclear power is very justifiably heavily regulated, has enormous time delays. We're never going to get a conventional, virtually never going to get a conventional reactor, let alone a brand new reactor going by the time we will know whether we made it or not on the clean energy transition. It's just not going to happen. I don't think. It's too hard, takes too long to permit something new.
But we might be in 2060 and still not there on zero carbon, right?
There'll be someone else's problem.
That's another example of how the technology is not necessarily the barrier. You know, the regulation and the permitting. I know it's a big challenge for nuclear power. I think we only have time for one last question, and I will pick the one that's directed for Diana and or Nadia. Do you think that local communities may be more accepting of a new mine if it produces ETMs? And if so, are companies using this in their engagement with local communities by trying to quote unquote sell the climate change benefits of new mining operations?
Again, I'm happy to kick off and Nadia, yep. I'll take the back end of the question first. I don't know whether companies are using this to sell at the local level, but what we are seeing is huge marketing campaigns starting to kick off about, you know, kind of clean copper, responsible steel. So we are seeing the sell on the clean part of the transition. In the advertising campaigns, we don't hear so much about the justice parts of it. So I think it is important to sell the clean energy benefits of these, you know, of these products. But it's really important not to gloss over some of the things that we've aimed to put on the table today. So advertising has its limitations, I think, is what I'm saying there. In terms of, you know, will communities be more willing because it supports the energy transition? I think that's a question for communities themselves, but I don't think it's necessarily a reasonable one. Can you guys be a bit of a sacrifice zone here locally so we can achieve the transition? I think we just need to be honing in on the impacts that we talked about. You know, what are the impacts on land? What are the impacts, whether it's dust, water, conflict, whatever the social impact might be if you locate, if you look at that location, the factors that we have to think about, and then the dynamic risks that are created by, you know, by creating any mine. And I don't think that necessarily that should be used as a sell. I think we should be focusing very heavily on understanding and managing social and environmental impacts, and as I said, looking to avoid if those thresholds are unacceptable, or otherwise looking to compensate well, mitigate and manage. So in some ways, it's what we've been saying all along. I think the levers are there at the moment to really be focusing in and honing down on understanding impact and actually dealing with it, doing proper studies and dealing with it. I think that the last two words is just, you know, equity and fairness is something that we absolutely need to bring into the equation at the local level. So yeah, I think that was Laura, and her work is really looking at some of the challenges in this area as well. So thanks.
Yeah, definitely. And just to kind of follow up and echo some of what Diana said, I think one of the biggest conundrums with this is that the impacts and the benefits don't accrue in the same place. And so that makes it very difficult to make that kind of argument, if you will, that, you know, having local impact is that acceptable for the greater good. And I think there's some of those justice questions that, you know, that I know Diana has been exploring a lot within her team. And I think as we move forward, and kind of this links to one of the other questions in the Q&A, I do think we're going to have to see, you know, a much more kind of aggressive approach in the way that we, you know, that approval processes have social and environmental issues front and center. Like Rick spoke about them being, you know, in terms of mining development, they're now the constraints. So, you know, how do we reimagine what approval processes look like so that communities have the right to say no, and you know, that we are embedding those local priorities front and center. And I think that companies will have to shift towards being able to show that they're able to you know, manage those or find opportunities that sell projects from a social perspective, as opposed to an approach that may have sufficed in the past, where it may not have been as necessary. So I think it's actually quite an exciting time in a lot of ways for social and environmental things to be prioritized much more than they have been in the past. So I'm very excited about what the future will hold in terms of positive developments in regulation and engagement principles. So I'll stop it there. Thank you, Walter.
Thank you very much, Nadia and Diana. And thank you, everyone. Really, I mean, I have really enjoyed this. Actually, you know, it's been really illuminating to have some of the specific things. I kind of knew about some of these discussions, but it's good to hear the specifics about some of the metals, for example. I didn't realize that some of them were actually that critical. I only have a couple of housekeeping things. The recording for this webinar will be available shortly, and we will have a link on the page, I believe. And there is also a third and final webinar in this series in mid-May, and the topic will be announced shortly. So without, if there is nothing else that the panel wants to add, I want to just thank you again for your time and thank the participants for joining us today. And I hope to see you in the not so distant future, maybe when things go back to normal physically here in Vancouver. We would love to welcome you for a visit. Thank you so much for your time.
Thank you, Walter.
Thank you.
Thanks, everyone.
Everyone.
Bye-bye.
Thanks, everyone.
Thank you.
Bye.